2023, Paper 1. Question 1. A stone is moved from one place to a place where the gravitational field strength is different. What happens to the mass and the weight of the stone? So we know the equation, W equals to mg. You know that weight is dependent on g. And mass is always constant. So answer C. Question 2. What is the unit of pressure expressed in base units? The formula for pressure, P equals to F over A. Okay. F is newtons, units, A is meter squared. But they want base units, so we can convert F equals to MA over area A. Area is meter squared. Mass is kg. Acceleration is meter per second per second. So answer is C. Question 3. What are the orders of magnitudes for the diameter of Earth and for the diameter of an atom? As you know, the diameter of Earth is 12,000 km, which is equals to 1.2 megameter. Diameter of an atom, it's 0.1 nanometer. Question 4. Forces of 3 newtons and 4 newtons act at right angle to each other. Which of the forces produce a resultant force R as shown in the direction? So we use the tip to tail method. Okay, so 3 newtons, 4 newtons. You can draw the resultant force with double arrow R. Question 5. The velocity time graph shows the motion of an object during a period of 30 seconds. What is the average speed of the object during this time period? You know the formula for average speed is total distance divided by total time taken. Okay, so the total time taken is 30 seconds. We know that the area under a velocity time graph equals to its displacement here. Question 6. A tennis player throws a ball vertically upwards as she prepares to hit the ball as shown. Air resistance can be ignored. What is the acceleration of the ball just as it leaves her hand and at its highest point? So here, acceleration of free fall is 10 meters per second per second. Both after leaving his hand as well as the highest point doesn't change, and it's downwards towards Earth because it's due to Earth gravitational acceleration. Question 7. A light ball is released from rest at the top of a very tall cliff. The ball falls through the air. Which statement describes the motion of the ball throughout its fall? So it doesn't decelerate, it speeds up until it reaches terminal velocity. This is when air resistance is equal to its weight. And it will look like this. The weight and the resistance R. Look at option D. Its acceleration is always equal to the acceleration of free fall. No. The acceleration due to the air resistance is actually proportional to speed. So at higher speed, it has more air resistance. Okay, question 8. An object of mass 5 kg, M here, is initially at rest. The object is acted upon by a force 10 newtons to the right. A frictional force of 5 newtons opposes the motion of the object. What is the acceleration? Question mark. So we know the formula F net is equals to MA, which is also equals to now the force minus the frictional force. Mass is 5.0. A is what we're trying to find. Capital F is 10 newtons minus the frictional force, 5.0 newton. You can find A. Question 9. The model of a bird is placed on the pivot. The model is pushed sideways through a small distance. The model starts to swing side to side repeatedly until it eventually stops in the position shown. In which position is the center of gravity of the model? So we know that the CG is definitely below the pivot. Okay, so at below pivot, the moment it's 0 because moment equals to force times perpendicular distance. So if perpendicular distance equals to 0, moment equals to 0, the object is in rotational equilibrium. So the pivot is here. If you draw the line of action right at the pivot, you know that it's at D. So I can label line of action of the weight. Question 10. The diagram shows 4 objects of equal mass. The center of gravity of each object is labeled G. Which object is most stable? So, for higher stability, you want the lowest CG and the largest base area. And that is actually in A, which is the lowest CG and the largest base area. Question 11. A gas at pressure of 25 newtons per centimeter square, small p, is contained in the cubical block, which is a cube, with a volume of 64 centimeter cube, means the volume is actually equals to length times length times length. What is the force exerted by the gas on the inner side of the block? We know formula, P equals to F over A. How you get the area is just length times length. So 25 equals to force over 4 centimeter times 4 centimeter. And you should get a force of 400 Newton. Next, question 12. The pressure due to a liquid of density P1 of 101.2 K at a depth of H1, 10 meters, it's P. What's the pressure due to the second liquid at a density of 300 kg per meter cube? So rho 2 at a depth of 80 meters now, H2. Okay, so here we know that the formula P equals to H rho G. We have the first one, H1 rho 1 G is actually equal to P, as given in the question here. Okay, now they're asking you to find the new pressure when it's at H2 rho 2 G. As you know, H2 is 8 times of H1 because H2 is 80, H1 is 10 meters. Rho 2, 300 and 1200, so it means it's 1/4 of rho 1. G is just constant. You solve it out as 2H1 rho 1 G. You can submit back in as 2P. So the pressure is 2P. Okay, question 13. Train of mass 40,000 kg m is moving along a straight track the velocity of train decreases from u, 30 meter per second, to v, 25 meter per second. How much work done? W, question mark, is how much work is done to slow the train down. So we know work done here equals to the change in kinetic energy. And the formula for kinetic energy is half mv square, and you minus the initial speed, half mu square. Next, question 14. A motor supplies 60 watts of power as it pulls a block at a steady speed along a horizontal bench. In 8 seconds, t, it pulls the block a distance of 3.0 meters, small s, displacement. What is the frictional force between the block and the bench? Friction, question mark. Use the first formula, P equals to work done over time. Question 1. We sub in P as 60 watts. Find work done, 8 seconds. We get work done is equals to 480 joules. Next, we know the second formula, work done equals to force times displacement. We sub in 480 for the work done. You can find the frictional force times a displacement of 3 meters. Okay, question 15. A 5.0 watt electric lamp, so P, is used for 8 hours, T, per day for 4 weeks. How much energy is transferred to the lamp? Use the formula P equals to energy over time. Same as the previous formula, work done over time. Energy over time. We can rewrite energy equals to PT. P is at 5.0 watts times 8 hours. We convert the hours into seconds. 8 times 60 minutes times 60 seconds. So this is for 8 hours, 2 seconds, times 7 days a week, and for 4 weeks. Next, question 16. What is the correct order for the density of these materials? As we know, gas is the lowest density, followed by liquid, then solid. Okay, so air is a gas, water is a liquid, aluminum is a solid. Okay, so answer is B. Question 17. Which process in the conduction of thermal energy occurs only in the metal conductor? So, density changes within the material. This is not. Okay, so this is for convection currents, not in conduction. Okay, free electrons gaining energy. So it's actually a sea of free electrons in metals gaining kinetic energy through the collision with vibrating ions. Okay, so option C is wrong because it's not ionic, it's electron vibration. And similarly for D. Question 18. Water at 0 degrees C contracts as it is heated to 4 degrees C. 3 students make statements about the water. Student 1, he says convection currents do not occur between 4 degrees, between 0 degrees and 4 degrees. So it's wrong, huh? It's not correct because convection current does occur because it's a change in density. Okay, between 0 to 4 degrees, water is actually a liquid. So there will be convection current. As water cools from 4, for student 2, water cools from 4 degrees C to 0 degrees C, each molecule expands. So wrong. Each spacing between molecules, okay, is reduced. So it contracts. Okay, as it becomes it becomes cooler from 4 degrees to 0 degrees. Student 3. Water at 3 degrees sink in water at 1 degree C. Yes, because since it becomes cooler, it contracts, becomes more dense, it sinks. So only student 3 is correct. Question 19. A piece of metal and a piece of plastic are placed in the refrigerator for a few hours. So which means it should have reached thermal equilibrium. Okay, why does a piece of metal feel colder than a piece of plastic? So the feeling is because metal is a better conductor of heat or thermal energy, means it actually conducts the heat away from your hands or the hands more quickly. That's why you feel that it's cooler or colder to the touch. Question 20. Which statement about the energy of an object is not correct? Okay, so thermometer measures the internal energy of an object. Wrong. It measures the average kinetic energy of an object. Part 2. Internal energy can be increased by doing work on an object. That's correct. Internal energy of an object is a measure of its total energy of its particle. Correct, because internal energy is actually made of IKE plus IPE. Option 4, when temperature of an object increases, T increases, the KE increases. So that's the speed increases. Okay, question 21. An iron container of mass 2 kg, small m, requires 9,000 joules of thermal energy Q to increase its temperature from 25 degrees C to 35 degrees C, delta theta. What is the heat capacity of the container? So heat capacity is capital C. You have the formula Q equals to capital C change in theta. Question 22. An immersion heater of power 50 watts, capital P, is placed in a 0.4 kg, small m, of a liquid. The specific heat capacity now is small c. The initial temperature of the liquid is 25 degrees C, so theta I, initial temperature. The heater is turned on for 0.8 minutes, so T, as you know, T you have to convert to seconds. 0.8 minutes equals to 0.8 times 60 seconds. The liquid is gently stirred. All the energy supplied by the heater is transferred to the liquid. The liquid does not reach its boiling point, so there's no latent heat of vaporization. What is the final temperature of the liquid? Theta F. You can use the formula P equals to E over T. That's the first formula, energy over time. So you have power as 50 watts, energy supplied so you try to find the energy, right? So it will be E over T, which is 0.8 times 60 seconds. Okay, then we use the second formula. Q equals to MC change in theta. Formula 2. In this case, your Q is the same as your energy E. You have M, you have C. Change in theta, it will be final temperature minus initial temperature. And here you can submit the values for E, M, C, and theta I, initial temperature. Okay, question 23. A liquid can change into a gas by boiling or evaporation. Which rule is correct? So for surface, it's only evaporation, because it must have enough Ke to escape the liquid. For boiling, it's throughout the liquid, okay, and because it's a change in state, it's at a fixed temperature. For example, water says 100 degrees C. Question 24. Which statement concerning wave motion is correct? So, A, wave transfer energy without the transfer of matter or the medium. Okay, so B is wrong. Transfer matter, wrong. C is wave travels always occurs in the direction of the vibration particle. This is longitudinal wave. Only longitudinal wave. Part D, wave travels in the direction at right angles to the particle's vibration. That is transverse wave. Only for transverse wave. Question 25. A stone is dropped into a pond at O and circular crest spread out from O. The distance from P to Q is 12 cm. The crest travels at a distance that is equal to 8 wavelengths at 4.0 seconds. So let's solve the first part first. These are all crests, which means the distance between this is 1 wavelength. Between P to Q is actually 3 wavelengths. So 3 wavelength is 12 cm. 1 wavelength is 4.0 cm. Okay, then the next one they say the crest travel at a distance that is equal to 8 wavelengths in 4 seconds. So 8 wavelengths in 4 seconds means 1 wavelength in 0.5 seconds. Okay, if 1 wavelength in 0.5 seconds means the period is 0.5 seconds. We know that frequency is equal to 1 over t, 1 over period. So 1 over 0.5 will give you 2.0 Hertz. D. Question 26. A ray of light in a block strikes the surface of the block and undergoes total internal reflection, TIR. Through which angle does the direction of the ray change? As it strikes the surface. So if the medium were the same, you should have gone straight. Okay, so now they're asking you this angle here. And using the law of reflection, we know that this will be 55 degrees because I is equal to R. Angle of incident equals to angle of reflection. So the direction, the angle of change will be 180 degrees minus 55 degrees minus 55 degrees, which will give you 70 degrees. Question 27. Statement 1 and 2 refers to signal passing through optical fiber of refractive index 1.5 small n. The speed of the signal in the optical fiber is 3 times 10 to the power 8 meter per second. You see, there is less signal loss in optic fiber than in copper cable. Which of the statement is correct? So 2 is definitely correct. There's less signal loss in optical fiber. However, question 1 is wrong because this is speed of light. As we know, refractive index n is equal to C over V. If the optic fiber has a refractive index of 1.5, means it should be 3.0 times 10 to the power of 8 over V. N is 1.5. V will be equal to 2.0 times 10 to the power 8 meter per second. So here it's wrong. The signal cannot be traveling at the speed of light in optic fiber. And this is actually the speed of light in vacuum. So question 28. A thin converging lens has a focal length of 16 centimeter. An object is placed at 4 different positions from the lens. How far from the lens is the object when the image is produced is real and magnified. So if you were to memorize the chart, you will know that for real and magnified, U must be more than focal point f and less than 2f. So how will it look like if you to quickly draw out the lens diagram? You have so if your object is here between f and 2f, first line cross the center, second and then you join them. This will be your image. Your object is here. Let's say your image is real, magnified, and inverted. Okay. So if your image is right at 2f, then it will be like a photocopier. Same size, inverted, and real. So if not, you can quickly draw this lens diagram and you can actually figure out that it should be between f and 2f. So this is f, this is 2f. Okay, question 29. Which region of the electromagnetic spectrum is used for communication? Is radio wave or microwave? This is for communications. Question 30. A sound reaches the man through two different routes. The first route is through water. The second route is an equal distance through air. The speed of sound in air is 340 meters per second. The speed of sound in water is much faster at 1.5 k meter per second. The man first hears the sound 0.5 seconds after the sound is emitted. How long after the first hearing the sound does he hear the sound a second time? So first you hear the sound from the water. So first sound is from water. Okay, so we use the displacement equals to velocity times time. 1500 multiplied by 0.5 seconds, which will get 750 meters. Then after you hear the second sound, which is from air. So T sound is the distance, since we have already had distance 750 meters over the velocity. 750 divided by 340, the speed of sound in air, we get 2.2 seconds. And so the difference in the sound will be 2.2 seconds minus 0.50 seconds. So it's 1.7 seconds. Next. Question 31. 3 charged rods are freely suspended as shown. Which statement is correct? So the force of attraction also depends on the distance. So since these are positive and this is negative, it should be attraction. So because unlike charges attract, whereas like charges repel. So Q and S should repel. But the distance between P and Q is larger. PQ is larger than the distance between Q and S. So P and Q is weaker than the force of repulsion between Q and S. Question 32. The diagram shows the pattern of an electric field surrounding two isolated point charges. So you can see that it's going inwards. So this must be a negative charge. And it actually forms this X here. It's actually known as the neutral point. Okay, so for negative charge, it's inwards. Positive charge, if you realize, is outwards. Question 33. A negatively charged copper sphere rests on an insulating mat. So initially it has 3 charges already. Okay, so now you bring a plastic rod that is negatively charged near to the sphere. It will start to attract the positive charge. Okay, while it repels the electrons, negative charge. So for B and D, the difference is that it should have actually 3 extra charges, because initially it has already 3 charges. Next, question 34. The circuit diagram of a torch is shown. The torch is switched on for 4 minutes T. You can convert to 4.0 minutes equals to 4.0 times 60 seconds, and the current in the circuit is 2.0 ampere I. How much charge passes through Q, point P in the circuit, and in which direction do the electron flow? So we know that the battery here is positive, negative. Conventional current flows from right to left. Electron flows the opposite, left to right. So it means electron flow is clockwise. And to get the amount of charge, use the formula Q equals to IT. Next, question 35. What's the definition of the potential difference across a component? A is wrong because it says charge passing through a component in unit time. Actually, it's trying to refer to this equation, Q equals to IT. The current in the component divided by the resistance of the component, wrong. I think it's trying to refer to Ohm's law, which is R equals to V over I. The work done to drive an electron through the component. So here is wrong because it's actually to drive a unit charge through the component, given by the formula V equals to work done over charge. Question 36. A battery is connected to a rheostat. The rheostat is also connected to a lamp as shown. The total resistance of the rheostat, okay, is actually 20 ohms. The section XY is 6 ohms, and the resistance of the lamp is also 6 ohms. What's the total resistance of the circuit? So in here, you can actually see that the rheostat is actually broken up into 2 parts. Okay. And what you can do is you can actually redraw this to look like this. Here the rheostat is 14 ohms. Here is 6 ohms. The lamp is 6 ohms. So we see that it's actually a parallel circuit plus a series circuit. And to find resistance, RT, we can actually solve for the parallel region first. 1 over 6 plus 1 over 6. You inverse it, and then just add the series part, plus 14. Okay, question 37. The resistance of a cylindrical wire P is 80 ohms. A second wire Q is made from the same material. Same material means same row. The radius of Q is 2R, twice the radius of P. The length of Q is twice the length of P. So, if length of P is L, length of Q is 2 times as long. Okay, so we use the equation R equals to rho L over A. We can convert the A, since it's cylindrical, to pi R squared. If R now is at 2R and L is at 2L, because twice as long, and the radius is twice, we can sub in back to the formula R equals to rho 2L over pi R squared, 2R squared. We can solve 2 rho L over 2 square, so 4 pi R squared. It becomes half of R. So this is R of Q, R of P. So R of Q, resistance of Q, is half of resistance of P. And that is half of 80, 40 ohms. Next, question 38. A 6-volt battery is connected to 3 resistors and an ammeter. So EMF is here. The reading on the ammeter is 0.3 ampere. So here, I is 0.3 ampere. The potential difference of 2 volts across resistor 1. So resistor 1 is 2 volts. What is the current at X and the PD across resistor 3? So since they are in R1 and R2 is in parallel, so they will have the same voltage. Here is the same I, since the I combines and comes back. So at X, the current should be the same at 0.3 ampere. For PD across R3, we know that V1 is equal to V2, and EMF is actually equals to V1 or V2 plus V3. Okay, so EMF was 6.0, the V1 was at 2.0. We can find V3 as 4.0 volts. So here will be 4.0 volts. Next, question 39. An electric heater is connected to the main supply using a 3-pin plug. Which is the correct position for the circuit for the switch of the heater? So a switch or fuse should always be connected to the live pin. Next. Question 40. The input voltage to a transformer in a power station is 3000 volts. So VP, which stands for voltage in the primary or input. The efficiency of the transformer is 100%, so there's no power loss. There's a current of 8 amperes in the input coil, so IP. There is 1000 turns in the input coil, NP, because primary. The output voltage of the transformer, VS. Okay, now they're asking the number of turns in the output coil and what is the current in the output coil. So number of turns in the output coil, NS, current, IS. We know the formula, VS over VP is equals to IP over IS, which is also equals to NS over NP. So first formula, the voltage, 120,000 over the primary, which is 3000, equals to IP. Your IP was 8.0 over IS. So you can actually find IS. Next one, the same thing. 3000 equals to NS over NP, and the NP was given as 1000. And that's the end of paper 1.